Low-cost Cyclone V dev boards are taking the Mr. FPGA community by storm. QMTech's board is available now for $100. But how does this board really compare to the Terasic board that we've all been using for the past few years? Is it worth buying? Well, stick around and find out, because today we're going to go deep on QMTech's Cyclone V dev board and see how it stacks up. The Mr. project runs on a Cyclone V SoC FPGA development board called the DE10-Nano. This is a board the company Terasic released back in 2017 and is now retailing for $225. If you think that's expensive, then you're not alone. Others in the Mr. community have felt the same way. And as a result, there are ongoing efforts to build a lower-cost Cyclone V board. A company called QMTech has already released a $100 Cyclone V dev board that runs Mr. out of the box. There's been a lot of questions about this board, so I want to focus this video on doing a deep dive of the QMTech board and help you understand the differences, benefits, and disadvantages of using this low-cost FPGA over the Terasic DE10-Nano board. Before we jump into QMTech's board, it's worth going back to the DE10-Nano and understanding what it really is. A lot of times when an FPGA enters the market, companies will make a development board for that chip. This gives FPGA developers a sandbox environment to play with, test out various features in, and develop their FPGA configurations on. And this is what the company Terasic did when Altera's Cyclone V SoC chip was released back in 2012. In 2013, Terasic released a dev board for the Cyclone V SoC, which they called the SoC Kit, or socket. This board provided a host of features such as additional memory, USB, Ethernet, and even a VGA DisplayPort. At launch, you could purchase the socket for a mere $300. Over the next few years following that, Terasic continued to release other Cyclone V SoC dev boards with varying features. And in 2017, they brought out the DE10-Nano that's known and loved by the Mr. community today. At launch, the DE10-Nano cost $130 and came with some additional modern conveniences such as HDMI video. Now, Terasic wasn't the only company to offer a Cyclone V SoC dev board. In fact, Altera sold its own dev board for the Cyclone V, though at a much higher price. And QMTech, like Terasic, has been making FPGA dev boards for several years. Their newest Cyclone V SoC board, which resembles Terasic's DE10-Nano, is actually not their first Cyclone V dev board. QMTech has had a Cyclone V board in market since 2021, though they did take a different approach with that board and built it as a modular architecture. As of this recording in August 2024, you can purchase the latest QMTech Cyclone V dev board for $100. When you do, you get the development board, a 5-volt power supply, a combination fan and heatsink, and a USB mini cable. Along with that, you'll find a 32GB microSD card in the onboard microSD card slot. And QMTech has already done you the favor of conveniently loading up the card with the Mr. software. It's definitely clear that QMTech knows its audience for this dev board. I've seen some skepticism in the Mr. community around the quality of the power supply that comes with this board. So let's start by popping it open and taking a look inside. You'll notice that this adapter has a transformer in the middle, taking up most of the space on the board. Underneath, you'll find a bridge rectifier, which converts the current from AC to DC. And there's also a voltage regulator here, with a large heatsink, which trims down the converted DC to 5 volts. This is a pretty standard design for a low-cost power supply. There's nothing crazy going on here. The only thing that really bothers me is that the prongs are connected to the board with some thin wire. We're drawing less than 2 amps here, so it's probably fine. But I would feel a lot more comfortable if the prongs were soldered directly to the board, like Terasic's power adapter. Regardless, the dev board just requires 5 volts. So really, you can use any 5-volt center positive power supply that can put out at least 2 amps of current, and it'll work fine. When you put the QMTech board side by side with the Terasic board, you can see that there are some similarities. The dimensions of the board and the mounting hole locations are all the same, and the HDMI port and power plug are also mounted in the same location. But that's about where the visual similarities end, because there's a lot that's different. The DE10-Nano has a micro USB port for the USB on-the-go connector. This is where you'd plug in your USB hub for USB controllers and accessories. The QMTech board, however, has a USB-A connector, which I actually prefer. You'll also notice that the DE10-Nano has 2 USB mini connectors. One connects to an FT232 UART chip, and the other connects to an Altera Max CPLD, which is configured as a USB Blaster 2. Now, if you're not an FPGA developer, then this is something you probably won't care much about, because the USB Blaster is an interface that's used to program and debug the FPGA. The QMTech board also has a USB mini port connected to a UART chip. However, it doesn't have the USB Blaster port. So if you're an FPGA developer, then you'll have to program and debug the FPGA on the QMTech board using the JTAG header with an external programmer. Another major difference is the pin headers on top of the board. The DE10-Nano has 2 sets of GPIO pin headers, which are connected to I/O pins on the Cyclone. The QMTech board also has both of these headers, and they connect to the same pins as the DE10-Nano. However, you'll notice that GPIO 0 is in a different location. And more importantly, the header is rotated 180 degrees. So for GPIO 0, pin 1 is here on this white square. But for GPIO 1, pin 1 is over here on the opposite side. Because of this, you'll need to install the MR memory module backwards. The DE10-Nano also has a set of Arduino headers, which are pin compatible with Arduino shields that you can attach to it. These are the pins that are used by the MR I/O boards for snack port connectivity. The QMTech board also has these pins, but they're located off to the side of the board as a set of double row pin headers. These are mapped differently than the Arduino headers on the DE10-Nano, so if you want to use an I/O board with it, you need to use some jumper wires to connect the pins correctly. There are some other differences, such as the lack of an LTC header, no onboard LED array, and the relocation of switches and buttons, as well as the microSD card slot. But if you're purchasing this board for a MR setup, then those minor differences don't really matter. The thing you're going to be most concerned about is that you can't connect your existing I/O board, and it won't fit in standard MR cases. Okay, so those are the main visual differences between these boards. Now let's go a little bit deeper and take a look at the chips, starting with the FPGA. It should be no surprise that both boards use a genuine Cyclone V SoC, which is a combination FPGA and ARM processor. And this is important for the MR because the ARM side of the chip, called the HPS or Hard Processor System, is what runs MR's Linux operating system. And the FPGA side is what runs the various arcade, console, and computer cores. But the model numbers of the chips do vary, so let's put them side by side and see what's different. First, the 5C indicates that both chips are Cyclone 5s. Next, the SE tells us that both are indeed the SoC version. So far, so good. But now we see the first difference. The next letter in the part code on the DE10-Nano is a B, but on the QMTech, it's an M. According to the Intel spec sheet, this portion of the code indicates whether or not there are any hard IPs built into the chip. A hard IP is a pre-configured function block, such as a PCIe controller, that's built directly into the processor. For the DE10-Nano, the B code tells us that there are no hard IPs. So the FPGA has to implement these controllers in programmable logic if it wants to use them. And doing so uses up logic elements that the FPGA could otherwise use. The M code on the QMTech board, however, indicates that this chip has a built-in hard memory controller. I don't think this is helpful for the MiSTer though. While many MiSTer cores do access external SDRAM, the memory would have to be connected to specific pins that the Cyclone dedicates to the memory controller, and not the general purpose I/O pins that MiSTer setups use for connecting a memory module. Moving on, the next three codes, A6, U, and 23, each indicate that the chip has 110,000 logic elements and is in an ultra-fine BGA package with 672 pins. After that, the QMTech has an A7N, while the DE10-Nano has an I7N. The 7 indicates the speed grade of the FPGA fabric, which are both the same here. And the N tells us that the chip's package is lead-free. But the A and the I reference the operating temperature of the chip. The I in the DE10-Nano tells us that this chip is meant for industrial use, operating in a temperature range of -40 up to 100 degrees Celsius. But the A on the QMTech chip stands for automotive use, which actually has a higher temperature range, from -40 to 125 degrees Celsius. So for the purposes of a MiSTer, both of these chips will operate exactly the same. And when it comes down to it, the Cyclone in my QMTech board is actually a better chip than the one in the DE10-Nano. But the FPGA isn't the only chip on board that matters. Similar to the DE10-Nano, the QMTech board also has two DDR3 chips that provide a total of 1 GB of RAM to the ARM processor. Terasic uses a set of chips from ISSI, which have a latency rating of CL9. This means that memory data is available on the bus 9 clock cycles after the read command is sent to the chip. The QMTech board, on the other hand, uses two micron memory modules with a rating of CL13. So while both boards have the same amount of memory for the HPS, the DE10-Nano's memory is lower latency than the QMTech's memory. To the left of the Cyclone on the DE10-Nano, there's an HDMI controller chip. This is an ADV7513 made by the company Analog Devices. And on the QMTech device, you'll find the exact same HDMI chip. Another chip that's exactly the same on both boards is the Ethernet transceiver. This one is made by Microchip Technology, and it has the part number KSZ9031RNX. This chip works in conjunction with the RJ45 jack to provide wired networking to the board. Now, when it comes to the MiSTer, many people rely on the USB interface for connecting controllers, Wi-Fi adapters, and other peripherals. The DE10-Nano uses a USB controller chip called the USB 3300. This chip functions as a USB on-the-go device and is what provides the USB host functionality for the processor side of the Cyclone V. And as it turns out, the QMTech board uses the exact same chip. Okay, so to recap so far, the QMTech board has an identical HDMI controller, network controller, and USB controller to the ones found in the DE10-Nano. It also has a slightly better version of the Cyclone V, but the memory chips respond a little slower, with 13 clock cycles of latency versus the 9 clock cycles of latency in the DE10-Nano. But despite these similarities, these two boards are far from identical. Terasic's DE10-Nano comes with more features for the FPGA developer to use. In addition to the USB blaster, there's also an accelerometer, an LTC connector for expansion boards, and an array of 8 LEDs that can be used for visual debugging information. But all these additional features aren't things that are used by the MiSTer. So on paper, the QMTech board compares pretty decently to the DE10-Nano. but how does it perform in practical use? Now, I'm not going to go do a test of running different cores in games. Others have already done that, and unsurprisingly, everything seems to run fine. But there are a couple of different tests that I do want to run. With fewer features on the QMTech board, I was curious as to whether or not it would be more power efficient. So I decided to set up each board with the same SD-RAM module and play the demo PlayStation ROM over HDMI with a wired USB controller connected. First up was the DE10-Nano. I connected everything up, turned on the power, and launched the demo ROM. I let the demo run for 5 minutes and manually sampled the current draw every 10 seconds. As you can see, on average, the DE10-Nano pulled around 1.43 amps, sometimes dipping a little below and sometimes raising a little above. I also wanted to take some temperature readings from the FPGA, so I used my thermal camera to capture that data during the test. And it looks like it got up to around 65 degrees Celsius after 5 minutes without a heatsink or a fan. So 1.43 amps at around 65 degrees Celsius seems to be our rough baseline. Then I connected the QMTech board with the same configuration. I fired up the PSX demo ROM, and after 5 minutes, my suspicions were confirmed. The average current draw of the QMTech board was around 1.22 amps, over 200 milliamps less than the Terasic board. Temperature-wise, the Cyclone chip performed about the same as the DE10-Nano, getting up to around 65 degrees Celsius after 5 minutes, so no surprises there. Now, 200 milliamp isn't going to save you a ton of money in electricity, but one thing this really helps with is a handheld MR device. This is something I've been working on for a few weeks now, and my intention is to open source the design and provide a build video so folks in the community can go build one and hopefully improve on it. If this is something you're interested in, keep tabs on me via X. That's where I'll be posting updates and sharing out the link to the GitHub repository. And that brings me to something else about the QMTech board, or rather I should say boards, because QMTech actually released 2 different Cyclone V dev boards. There's the one that I've been talking about so far in this video, and there's another board with the MR's 128 megabytes of SD-RAM built in. You'll notice that this SD-RAM board variant is missing the GPIO0 header. And if you turn the board over, you'll find 2 SD-RAM chips soldered to the underside of the board. Because of this, it provides a complete standalone MR setup, assuming that you're okay with using HDMI output and a single USB controller. And it should be no surprise that this is the board that I'm using in the DIY MR handheld. In fact, one of my design goals was to make the device as thin as possible without having to modify the Cyclone V dev board. And the only reason I've been able to meet that goal and keep the thickness under 27 millimeters is because the SD-RAM chips are already built in. Another thing that's interesting about this board is that there's a 40-pin FPC connector underneath. And if you look at the schematic, you'll notice that this connector breaks out the display pins. I've been shopping around for different screens with this interface built in, because if I can find the right one, then I think I can make the handheld device a few millimeters thinner. Before I give you my overall thoughts and wrap this video up, I want to point out a concern that I've seen some folks raise, and that's the quality of the QMTech board. Generally speaking, the quality looks okay, but there is at least one weakness that Lou from Lou's RetroSource pointed out in his review a couple weeks ago. Lou found that after repeatedly plugging and unplugging the power supply, the power connection to the board would intermittently cut out. Now, if you look at the barrel jack connector, you notice that it's a surface mount component, and that's not the best choice for a part that's going to have a lot of stress put on it. QMTech really should change this out to a through-hole part in future board revisions. But if you're having this problem with your QMTech board, you should be able to fix this by firing up your soldering iron and putting down some fresh solder on those joints. I wasn't having this issue, but I went ahead and preemptively reinforced my barrel jack connector with more solder just as a preventative measure. Alright, so what's my overall take on the QMTech Cyclone V dev board? Well, if I were an FPGA developer, I might consider forking over the money for the DE10-Nano in order to get some additional features that I as a developer would care about. But if I was buying a Cyclone V dev board to put in a MiSTer, well, for me, it's no contest. Why pay over double the price for a DE10-Nano when the QMTech board does the job? I know some folks will stay away because you can't easily reuse your I/O cards. But QMTech has already released the design for their own analog I/O board, which has additional USB ports built in, as well as a real-time clock. And while the price isn't known right now, I highly doubt that it'll put the total cost anywhere near the cost of the DE10-Nano. And if you're looking to squeeze a MiSTer into a smaller form factor, the QMTech board with the SD-RAM chips built in is a great deal at $130 if you can find one. At the time that I'm recording this, both QMTech boards are out of stock, but given their popularity, I'd be very surprised if more weren't coming soon. Alright, that's all the time I have for today. Is this board the one for you? Well, let me know what you think in the comments below. I'll see you next time, but until then, as always, go make something cool.